jump and try and get the semester finished before the end of the semester. All right. When we talk about transformations yesterday, or day before yesterday, we have horizontals and vertical. In an equation, how do you know if the shift or the transformation, if it's horizontal? Kind of. Yes. These occur inside the function. And vertical? Very good. Occur outside the function. So which letters were inside? No, look at your notes.
C.
Just C?
C and D.
Yes, very good. And outside are? Very good, because our function looks like this. If it's inside, do the opposite. Like, for example, if there's x minus 2, then which way do you move your graph? You move it to the space, to the right. If it's outside, if it's vertical, it's outside. And you do what it says. It is what it is. And that's what we're going to talk about the first part this morning. So far, so good. So if you get the sheet that I gave you, we're going to look at this. Here is our function. Ah, yes, there's something in the back of the room. Oh. Here's the function. Here are the 5 changes we're going to do. We're going to redraw the graph according to these transformations. So for the first one, A, this one's saying g of x equals 2 times f of x. B says h of x is 1/2 of x. Let's look at those two first. So what is this one telling me to do? Since it's outside the function, what does it tell me to do? No. But of what? Not a reflection.
Isn't it?
Which is what value? What value of the here? All we have here are points. The y value. Because remember, y is equal to f of x. What this one tells me is multiply each value of y by 2. So for the first one, we have -5, 0. If I multiply the y by 2, what do I get? So I get, just stay at -5. The second point is at -2, 2. So what's the new point? -2, 4. So at -2, I go up to 4. At 0, 0, it stays there. At 2, -4, it goes down to -8. And at 4, 0, it stays there. And so my new graph, the only thing that happened was since the 2 is outside the function, all it did was make the graph a lot stretchier. It had a vertical stretch. And what happens to the next one at B? Which is the same thing as, this is the same thing as take the y values and divide by 2. So at negative 5, 0, it stays at negative 5, 0. At negative 2, 2, it becomes well, yeah, it's take the y value divided by 2. It's 1. So at negative 2, it becomes 1. At 0, 0, it stays there. At negative 2, 4, it becomes it becomes 2, negative 2. So 2, negative 2. And at 4, 0, it stays what it is. So what this one tells me is my graph is a vertical shrink. I compress it. So far, so good. Now, C and D happen inside. C is it is lose these points. C is R of X is F of 2X, and D is S of X is F of 1/2 X. So remember our graph. What happens here in our graph? It happens inside. So what does that mean? It does the opposite. So that change here. If it's inside, it's the X value. So what does that one tell me to do to my X value? Divided by 2. So the original X value was negative 5. So what is it now? Negative 2.5. So it's negative 2.5. And it stays at 0 because the Y value doesn't change. How about at negative 2, 2? The next point was at negative 2, 2. So it becomes negative 1, 2. At 0, 0, it remains the same. At 2, negative 4, it becomes it'll be 1, negative 4. Because you only change the X values. And the last one was 4, 0 originally. It becomes 2, 0. You can't just say 2. You have to give me a point. I'm changing the point location. So what happens to this graph? What kind of shrink? So horizontal shrink. Why do we know it's only horizontal? Because the verticals stay the same. All right, the next one. What's my first point there? Negative 10, because it's 1/2 X, so it goes to negative 10. And it stays at 0, negative 10, 0. What happens at the next point was at negative 2, 2. What does it become? -4, 2. There's nothing to think about. Just only thing you have to worry about if it's inside is the x value. If it's a fraction, you multiply. What about at 0, 0? Stays there. The next point was at 2, -4. What happens there? Four, -4. And the last one is 4, 0. What does it become? Becomes what? That's where it started off. 8, 0. Remember, it's opposite. Since it's a fraction inside there, what happens horizontally to the graph? It stretches horizontally because it's a fraction. And the last one, t of x is equal to f of -1/2 x. So what happens here to all my values? What's that? Multiply by -2. So, but when you multiply by -2, what happens to the graph? Because remember, treat the signs and numbers separately. What happens to, what does this tell me to do? No. What does the negative tell me to do? No. No. There is no move. Look at your notes from yesterday. What happens when there's a negative in front of the x on the inside? What happens? Look at your notes from yesterday. Oh. Look at your notes, everybody. What happens to the graph when you have a negative in front of the x in the function? Look at the square root example we had. Look for that example. Whenever there's again, your notes, it helps if you look at them at least once in your lifetime. Or don't take them. Don't waste your time. Define opposite. What happens to that graph? It goes to the other side. Yes. So what do you call that? A reflection. Whenever you change the sign of x inside the function, reflected across which axis? The y-axis. So what this means is our graph gets flipped across the y-axis. So in other words, our original graph, let me draw it over here again. It was at -5, 0. -2, 2. 0, 0. to -4 and 4, 0. So the negative tells me that my graph is going to flip across the y-axis. In other words, all these points are going to this side, and all these points are going to that side. So if I take -5 and multiply it by -2, what do I get? +10. It's over here now. And it's at 0. At -2, 2, what changes there? So I'll take -2 and do what with it? Multiply by -2, because it's negative. It becomes +4. +4, 2. At 0, 0, it stays the same. What happens to the 2, -4? It becomes what? No.
2 times 2.
This is 2. What do I multiply by? Which becomes, so it becomes what? What's the new point? No,
Oh, wait, wait.
because this stays the same. So it's -4, -4. And the last point at 4, 0 becomes -8, 0. So there's my new graph. Because it's negative in front of the x inside the function, I have to flip it across the y-axis. And then I just multiply. So basically, I take -2, because that's what this one negative had, and multiply to each x value. Y stays the same. Because the y's only change if there's a number outside the function.
So why would it remove that inside the function? You have to do it.
Good question. Because if I had f of x plus 2 equal, let's look at, let's say we're looking at a square root number. What do we know about inside the square root? What's the smallest number we can have inside there? 0. So if we take this equation, set it equal to 0, this says +2, and so it becomes -2. Because that's where it makes it a new 0. It also all started from the circle we had, the x minus h, y minus k. So whenever we have a shift where we have to go opposite direction because we have to make that transform it back to. So if this, what does x have to be to make this 0? -2. So it's the opposite of the inside function, right? Because every function, all transformations, you always start off from 0, 0. You notice what? We'll look at the next example. We should look at the next example. Everything starts off at 0, 0 and builds from there. It's the same graph that we just had. But now I want to transform it into this equation. So what's the first shift that we have there? No. Where do you always start? Look at your notes from yesterday. Everything starts from the horizontal shift. What does that tell me to do? Where does my graph shift? How many spaces? So each one of these points, I shift it to the right 3 spaces. So I add 3 to which value? To the x, because it's inside. So -5 plus 3 becomes -2. -2 plus 3. So we add 3 to x. -2 plus 3 becomes 1. So it's at 1, 2 now. At 0, 0, it becomes what? Becomes 3, 0. At 2, -4, it becomes 5, -4. 1, 2, 3, 4, 5, -4. And then at 4, 0 becomes 7, 0. So that's 1, 2, 3, 4, 5, 6, 7. That should be 7. So my graph looks like this. All I did was shift it to the right 3 spaces. That's what my transformation said. Always start off with your horizontal shifts. See what x does. Is there any coefficient in front of the x? Here's our function. Is there a b value? Is there a b value? Where's b? In front of the x. Yeah, so there's no value. So there's, what does b value do? It tells us whether we shrink or stretch horizontally. So this thing stays the same, like horizontally. All we do is a horizontal shift. There's no stretching or shrinking horizontally. So what's the next thing we change? Building up from inside here, where will we go? We'll look at the side. They have a 2. What does the 2 tell me to do? Treat the signs and the numbers separately. First, you do what? You multiply by 2. We haven't gotten to the minus sign yet. Don't try to overdo everything you're doing right now. Take it step by step by step. So we multiply what by 2? The y values. So here we have all the y values. So the x's stay the same. So we have -2. What's the y value here? 0. So it stays at -2, 0. What happens at this point? What's the y value here? What happens to that one? It becomes 4. So the new point is at where? No. What's that location? Yeah, you should have it on your paper in front of you. You don't look at the screen. So it's at 1, 2 right now. What does it become? 1, 4. Because it says take all the y's and multiply by 2. The next one becomes what?
It's at 2 right now. The x value is at 2 and the y value is at 0. Or when we multiply the y value is 0.
It should be at 3, because remember, we shifted 3 to the right. It started off at 0, 0. We're at 3 now. So what's the new point for that one? It's 3, 0, because only thing you do here is multiply y by 2. That's what this says. Multiply the y value by 2. What's the next point going to become?
Oh,
We've got another point here. And it's not 4.
5, 4.
No. What's this location right now?
5 negative.
5, -4. So what does it become with this transformation? 5, -8. There's 4, 5, -8. And the last one becomes what? It's at 7, 0. It stays at 7, 0 because there's no change with the y-axis. So all we did there was stretch it vertically. Because we had a 2 out in front, we stretched it vertically. What's the next shift we do in our function? What does it tell us to do next? We did the inside. We did the 2. Now what do? What's that? Did we do everything so far? We didn't do the negative. What does the negative tell me to do? What do you mean? Of what? You can't just say that. You have to give me relative to the points. You can't just say negative, positive of what? What's that? Mirror of what? What's going to happen? It's a vertical reflection. It's going to flip across the x-axis. So if you're going to use all these words, you have to tell me what's going to happen. You can't just use x, y, negative, positive. You have to tell me what's going to happen. Because the negative is outside the 2, that means it changes all of these points from positive to negative and from negative to positive. So it flips it across the x-axis. That's called a reflection. So now we take all of our y values and just change the sign of our y values. Because that's all this x does is we've done this already. All we got to do now is change the sign of y values. So for the first one, what's the y value of this one? 0. So it stays the same. So we're at -2, 0. So our first point is at -2, 0. What's our next point? It's at 1, 4. So our new point becomes 1, -4. So we go to 1 and down to -4. The next point is at 0. Does anything change there? No, because 0, nothing changed. So it stays at 3, 0. The next point well, let me go ahead and label these. That's at 2, 0. This is at 2. This is at 5, -4. This is at 7, 0. The new shift becomes -2, 0. 1, 4. 2, 0. 5, -8, 0. So all we do is take the y value and change it now. So we're on this one stays the same, -2, 0. This one becomes 1, -4. This one stays the same, 2, 0. The next point was at 5, -8. It becomes what? 5 positive 8. So at 5, we go up 8. And the last one was at 7, 0. It stays at 7, 0. So what this tells us, here's our graph now just flipped. And then write the equation down what we originally started off with. It was negative 2f of x minus 3 plus 1. Remember, whenever you do transformations, you always work inside out. First thing we did was here. The second thing we did, the third thing we did, what's the fourth thing we're going to do? Yeah, we do now, the last step, always your vertical shift. Nothing changes there except the whole graph itself. So here it tells us to do what? How do we change it? What actually changes? That's it, just the Y value? Both of them, because it's a vertical shift of the entire picture. So everything changes. For example, this one here at negative 2, 0, it becomes negative 2, 1. At 1, negative 4, it becomes 1, negative 3. At 2, 0, it becomes 2, 1. At 5, 8, it becomes 5, 9. And at 7, 0, it becomes 7, 1. We took that entire picture and we moved it up one spot. Because remember, whatever happens on the outside is the Y values, whatever happens inside is the X value. But the whole graph changes. All right. That will take you some time to go over and review, but it takes practice because do it step by step by step by step.